In this video, we're going to learn how to solve cube root equations. So we have 4 steps for solving cube root equations. We always want to isolate the cube root, and then we're going to raise both sides of the equation to the third power, because raising it to the exponent of 3 will undo the cube root, just like how subtraction undoes addition. They are inverse operations. Step 3 is we're going to simplify and solve, and step 4 is we're going to check for extraneous solutions. Just like with square root functions, whenever we raise both sides of an equation to the third power, that equation might have some extra solutions that the original equation did not. So we will always have to check our work. So let's go ahead and try example 1. It says solve each equation and check for extraneous solutions. So if we look at example 1, we have 5 times the cube root of 4x plus 3 is equal to 15. We want to isolate our cube root. Right now our cube root is being multiplied by 5. So to undo multiplication, I'll do division. 5 divided by 5 is 1. So that's going to leave me with the cube root of 4x plus 3 is equal to 3. Now our cube root is isolated. So to undo the cube root, we will cube both sides. The cube undoes the cube root, and that leaves me with 4x plus 3. 3 cubed is 27. From here, I can undo addition by doing subtraction. And I'll get 4x is equal to 24. And to undo multiplication, I'll do division and get x, let's change that to a 4. Excuse me. And I'll have x is equal to 6. So let's check to see if this is a solution or not. So if I check x equals 6, I'll have 5 times the cube root of 4 times 6 plus 3 is equal to 15. So I'll have 5 times the cube root of 24 plus 3 is equal to 15. So 5 times the cube root of 27 is equal to 15. The cube root of 27 is 3. 5 times 3 is 15. 15 equals 15, so 6 is in fact a solution. On example 2, I have the cube root of 3x minus 4 is equal to 2. Well, my cube root is already isolated, so I can go ahead and cube both sides. The cube undoes the cube root, and that leaves me with 3x minus 4. 2 cubed is 8. To undo subtraction, I'll do addition. And I'll have 3x is equal to 12. To undo multiplication, I'll do division and get x is equal to 4. So let's go ahead and check this. So I'll have the cube root of 3 times 4 minus 4 is equal to 2. 3 times 4 is 12. 12 minus 4 is 8. The cube root of 8 is 2. 2 equals 2, so 4 is a solution. Excuse me. On example 3, when you have more than one cube root, you need at least one of them to be isolated. The cube root of x plus 6 is isolated on the left-hand side. So we can go ahead and undo the cube root by cubing both sides. The cube undoes the cube root, and that's going to leave me with x plus 6. On the right-hand side, I have a product being raised to a power. So remember, you got to distribute to both factors. 2 cubed is 8. And that's being multiplied by the cube root of x minus 1. The cube root of x minus 1 raised to the third power is just x minus 1. From here, I can go ahead and use the distributive property. So I'll have x plus 6 is equal to 8x minus 8. Next, I want to get my x's on the same side of the equation. So I'm going to go ahead and subtract 8x from both sides. And so I'll have negative 7x plus 6 is equal to negative 8. To undo addition, I'll do subtraction and get, I'm going to move this over here. So I'll have negative 7x is equal to negative 14. And then to undo multiplication, I'll do division and get x is equal to 2. So I'm going to go ahead and check my work to see if this is in fact an actual solution. And so I'll have the cube root of 2 plus 6 is equal to 2 times the cube root of 2 minus 1. 2 plus 6 is 8, and 2 minus 1 is 1. The cube root of 8 is 2. The cube root of 1 is 1. I'll have 2 equals 2, and that is true. So 2 is a solution. Let's go ahead and look at example 4. On example 4, our cube root is already isolated, so I can undo the cube by cubing both sides. And so I'll have x minus 2 is equal to 8. To undo subtraction, I will do addition and get x is equal to 10. So to check that work, I'm going to plug in 10 for x. So I'll have the cube root of 10 minus 2 is equal to 2. 10 minus 2 is 8. The cube root of 8 is 2. 2 equals 2, so 10 is a solution. On example 5, we have 2 cube roots. The one on the right is isolated, so we can go ahead and cube both sides. 2 cubed is 8. The cube undoes the cube root, and that leaves us with x. So if we wanted to, we could rewrite this as 8x. On the right-hand side, we have the cube root of x plus 7 being raised to the third power. The exponent of 3 undoes the cube root, and that leaves me with x plus 7. So from here, I want to go ahead and get my x's on the same side. So I'm going to subtract x on both sides and get 7x is equal to 7. To undo multiplication, I'll do division and get x is equal to 1. So when I plug this in, I'll have 2 times the cube root of 1 is equal to the cube root of 1 plus 7. The cube root of 1 is 1. 1 plus 7 is 8. 2 times 1 is 2. The cube root of 8 is 2. 2 equals 2, so 1 is a solution. And then on our last example, we want to go ahead and isolate that cube root of x plus 4. And so my first step is going to be to add a 5 to both sides. So I'll have the cube root of x plus 4 is equal to negative 1. Now that my cube root is isolated, I can undo the cube root by cubing both sides. The cube undoes the cube root, and that leaves me with x plus 4. Negative 1 cubed is negative 1. To undo addition, I will do subtraction and get x is equal to negative 5. So let's go ahead and plug this in and see if it works. Excuse me. So I'm going to have the cube root of negative 5 plus 4 minus 5 is equal to negative 6. Negative 5 plus 4 is negative 1. The cube root of negative 1 is negative 1. Negative 1 minus 5 is negative 6. Negative 6 equals negative 6, so negative 5 is a solution.